Hey guys, this is Hui. Welcome back to another video. Let's continue to get into RAC. So first of all, let's take a look at the notification. In general, we add the observer directly, but let's see how it looks in RAC. I use RAC add observer for name. This name is the value I want to observe. For example, I'm here to observe the keyboard did show notification. Then object. The object you can pass anything, because this object is mainly used for communication. Once we call this function, one thing will be generated here. It's called signal. Let's take a look. Look, it will return a RAC signal. If you still remember the concept I mentioned in the last video, that is, everything is a signal. Bounding it is here. It's a category of this class. When it's extended here, it returns a signal. With this signal, we can't help but think of subscribe next, then print something. Then run the code. You can use Command-Shift-K to call the keyboard out. Look, this information will appear automatically. If you want to add a notification by yourself, I mean a traditional way, you have to respond and add selector. Then use this selector method name to find the corresponding method, and then call the specific IMP underlying implementation. It's hard to get, but if we use RAC, we can write it directly here. Why RAC is so powerful? Let's take a look. Look, as you can see, because it has a category of almost all the commonly used in Objective-C. And RAC also has its own core classes. And here is a question for interview. If primary class and category has the same method name, which one will be called first? If you are not sure, you can take a look at my previous video. It's called Play with Method Call Order. Okay, this is for notification. Then next, let's take a look at Delegate. I write something. And here, which requires a method name at the runtime, a selector. Then we can add a text field date begin editing. And in this case, we created a delegate. And we also need a response. So we need to add a protocol. Then from protocol. And what's this? And here should be an interface of the protocol. I use the UI text field delegate. With this one, it will also return a corresponding signal. Then the next step is the same. Subscribe next. And print something. Because everything is a signal. As long as there is a signal, you can subscribe it. Run the code. And there may be a small issue here. And let me add something different. And try again. Okay. Look, it doesn't work. Why it's not working? And here is a small detail you need to pay attention to. Because RAC doesn't know which text field is observed. The UI object here is unsure. So we need to specify which text field has this delegate. So let me fix it. And try again. And look, and now it can respond all the information from this text field, such as text content. We can directly operate the values in RAC. We even don't need to write this line. I can delete it and try the code. Look, there's no problem. The only thing that looks not really nice, because here will be a warning. We used to forget to write delegate sometimes, but after we use RAC, we don't need it. But in order to not show this warning, I still add it back. Then what's the benefits we write delegate like this? As you can see, my whole function and the logic in one place. It's very convenient. If we are using a traditional way of writing, we need to respond a lot of things. It's very troublesome. However, since we have a functional programming idea, everything we need is just encapsulate all the things we needed inside, then return a signal, and we subscribe it if we need. Okay, I'm wrapping this code to a message. So next, let's take a look at the usage of RAC in the UI. For example, let's start with our most familiar UI button. Use button RAC signal for control events. Then I type UI control event touch up inside. And this function also will generate a RAC signal. So with the signal, we will do the same, subscribe it, print something, try the code. And look, every time you click the button, it will print accordingly. Okay, this is the button. Next, let's take a look text field. Text field, RAC text signal. This is not the same. This is the property. So another question, if you can use point to directly find the property, what's the operations needed inside? Yes, it's association. Let's take a look. In the category, the get method is called. It's rewritten here, but just the corresponding instance variable is not added. When this is done, it returns a RAC signal. Then we can do the same. Call subscribe next. Print something. Run the code. And look, it allows you to observe your text field. For example here, it can observe the length of the string. You don't need to do some delegates, callbacks, etc. And RAC is very simple and refined. Okay, let's talk one more. The gestures. This is also very common. Tap gesture. UI type gesture. Block init. Regarding init, we often use the init with the target action. But if we have REC, we don't need to use it. We only need its object. For example, I do something for the label. And here we add a tag to it. So next, let me bound this tag to REC. With this signal, I believe you should know what's the next step. Yes, subscribe it. Like this. In before, if you want to do it without REC, you need to deal with action, respond to the selector. Now you don't need it. You can directly do things here. And incidentally, why there are so many subscribe next? Because when the signal is generated, it's just a cold signal. And only we subscribe it, it can become a hot signal. What do you mean? After the signal is generated, it only means you have a signal string. However, the signal can actually be used, which is actually from this subscription. Very typical example. You are watching my iOS video on YouTube. All the videos are signals. But as a user, if you don't subscribe my channel, and YouTube won't tell you, hey, there is a new video today. The iOS video is updated. And then system will only send you a signal after you subscribe to my channel. So, you need to subscribe my channel first, then you can get it. If you don't subscribe it, it means that the signals are more or less like broadcasting. Broadcasting means the waste of performance and resources, because not everyone is interested in your video. And this is the role of the subscription. Okay, that's about it for operations of the UI. And definitely, you have to practice more by yourself. I will wrap this code to another place. Finally, I will talk about a very classic thing in the REC. This is about the data handling. It's called sequence. There is a sequence in Swift, and there is also a sequence in REC. For example, I'm writing a very simple array. With this array, if we want to traverse it, we normally just simply use a for loop. But in REC, it's different. REC thought, compared to for loop, REC has a more superior way. What is it? Let me write. Okay, run the code. Look, what's this? This is traversal. The REC made a new data structure, the sequence. Our array, dictionaries, and more, they all can be used. Since we mentioned the dictionary, then let's take a look at the usage of the dictionary as well. Name, foks, age, 18. The usage is same as the array. Okay, run it. Look, there is a new data structure called tuple. If you have used Swift, you will be very familiar with it. Tuple is not the same as the arrays or linked list, etc. And here we use RAC2tuple, what it is inside. This is a second-order array. This data structure ensures that we can use it even better. And there is another thing in RAC2tuple. Look, that is RAC2tuple. RAC2tuple is just a subclass of RAC2tuple. It has two values, first and second, which completely rewrite the entire data structure. The internal code for tuple may be hard to see in Swift, but we can see its internal structure here. Let's take a look now. Very interesting. Look, have you seen it? The internal structure is very simple. It's incredibly simple. For example, look here. It first gets the value of array, then use for loop to take them out, then add these values to a new array. Next, to use the backing array to build it up. Then look up the values in the linked list one by one. And finally, find the value, and initialize and construct it to a tuple structure, which is very interesting. Okay, I just talked to here for tuple. For this sequence, we just remember that it is not a simple object. It has been encapsulated into a corresponding sequence. When we get this sequence, or when we get this data structure, then it will generate the corresponding signal. You may ask, why is it necessary to encapsulate this into a sequence? Why does array or dictionary not generate its own signal? When you talk about the data structure, you might think of array, dictionary, and so on. But in fact, they are similar. Since they are similar, why do we have to do some extra operations, right? If the array will generate a corresponding signal, and the dictionary will generate another corresponding signal, as well as for set, generate another corresponding signal, that would be too much trouble. So, as long as it is a collection type, we encapsulate it into a sequence. Because there is already a signal in this sequence, it's particularly good to use. On this point, we can slowly experiment. Okay, this is gonna be for today's video. Thank you guys for watching, and I will see you in the next one.